Good evening, I am Mr. Ish. Let's continue with this very important topic, generally graph transformations, but here looking very specifically at reflections. If you have a certain function, f of x, you can have two types of reflections based on the coordinate axis that you're looking at. If you place a negative sign outside of your function, you can reflect that graph across the x-axis. If you place that negative sign but within the confines of your functions, you'll end up reflecting it across the y-axis. This right here is an example of a graph which looks something like this, but we reflected it across the x-axis, so it became like this. This right here could be a good example of something which, if supposedly the function was like this, it became reflected across the y-axis. You see here we're seeing y-axis reflection. Here we're seeing x-axis reflection, but we need to make this more meaningful in terms of two questions that we will provide for this specific video. Alright, first question. Remember, these have to be specific and they have to be meaningful in the sense that you can do something in terms of the type of questions you can see, because they're not going to be general, they'll usually be specific. We have a specific graph over here, a radical graph. Radical graphs are excellent for understanding reflections. Graph root x plus 1 and find the equation of a graph reflected across the x-axis. Well, let's start with the graph of this equation, and you know it's root x plus 1. We're thinking here about that specific thing we were talking about in terms of translations, x plus h within some sort of binding parentheses. Well, here we're seeing an x plus h, and we know we're shifting here to the left by h units, which is 1. So our vertex here is minus 1 comma 0, and then a radical graph would be generated in that direction. If we have to find the equation of this same graph which is reflected across the x-axis, we're reflecting it across this axis, not rotating it but reflecting it. You know our graph must then be with the same vertex, minus 1 comma 0, but it's going to be shifted here. And what will that be? I showed you at the very beginning, these are the types of graphs which look like minus f of x. If the original function was f of x, you're placing a minus at the beginning, and then therefore this graph must be minus root x plus 1. And there you would have it. That would be your answer right here, and you would be right. Alright, let's look at this question, and I promise you this will be very interesting. We have to graph root x minus 2. And then we have to find the equation of this graph which is reflected across the x and the y-axis. So we'll have double reflections over here. Let's start with the graph, and this right here is my original function f of x. What's the graph of f of x? You know we're looking here at something which is in the form of x minus h. When you're seeing x minus h within some sort of binding parentheses, you're thinking about movement to the right. And by right, by 2 units, we're having a specific vertex here at 2 comma 0. X minus 2 would look something like this. If we were to modify this such that we can reflect this across the x-axis, what can we do? We're looking here in terms of the x-axis reflection. Well, we could really just convert the graph into minus root x minus 2, and then you would be looking at, again, with the vertex at 2 comma 0, but then it's reflected downwards across the x-axis, but now we need to somehow reflect it across the y-axis. And how can we do that? How about we modify the graph from within? Because to do reflection across the y-axis, we need to somehow convert something which looks like this into something which looks like this, with the minus within the binding parentheses of the function. But you can't really do a radical which looks something like this and then just put a minus in a radical, because a minus within a radical leads into a imaginary number, especially when you have even roots. You cannot have a negative in a radical such that you end up with imaginary number solutions, but you can flip things around within this and you can modify the entire equation. How can we do that? And I'll show you right over here. If our equation within the radical is just x minus 2, ignore the fact that we have a radical sitting outside. We'll hit everything here with a minus, and then we're making it look something like this, minus x, where this here represents x. And then when you open this up, you get what? You get 2 minus x, don't you, right? 2 minus x. Now places 2 minus x within the radical, and our next function becomes 2 minus x. And then we can still have this minus because we need to have a double reflection. And what we end up getting is, again, vertex 2 comma 0, but now instead of pointing this way, we're going to take the same graph and we're going to modify it such that it's going to reflect across the y-axis, and the graph will become like this. And you have to be very cognizant of this reflection across the y-axis, which is generally more difficult to understand, to comprehend, and to mentally visualize, versus a reflection across the x-axis that's very easy to understand. This is slightly a little bit more difficult, and you need to practice with these type of techniques to enable such changes. But here is a question done for you. This is my original graph. This is the graph of that same function reflected across the x-axis. This is the graph of that same original function reflected across the x and the y-axis. And with that, we end this video. Thank you for watching. Stay tuned. Have a nice day.